Hey, what's happening, you guys? Well, I'm going to go over a couple things that we did before spring break, and we're going to start with polynomials, all right? And if you weren't in class, because there was a few people that were away, I just want to quickly review, and I want you to take a look at this. So polynomials, poly means many, all right? So in class I sang a song, Polly Pocket, she's the one, because she's got so many different pockets, all right? So when we want to write polynomials, I'll give you a quick example here. X squared plus 2x minus 1. That would be an example of a polynomial. It's made up of multiple terms and with a variable, all right, and sometimes some constants, all right. So first off, we used algebra tiles, and I want you to imagine that we've got a square right in here, and we're going to make each side x and x. Now, if you ask yourself, well, how do I find the area of this square? Well, I take my length times my width, and I get x times x, which equals x squared. And if we go back to our exponent laws, we actually have an exponent of 1 there. We don't write the ones, but when we have the same base, we can add our exponents when we multiply, and therefore we get the x squared. All right? So what if I had more than one of these? I had x and x. Well, I've got the area of this is x squared, and the area of this is x squared. X squared plus x squared, well, there's like an invisible 1 there and an invisible 1 there. 1 plus 1 is 2, so we get 1x squared plus 1x squared, and we get 2x squared. We have two of them, all right? So that's when we've got our squared, x squared. And well, next what we're going to do is we're going to have some strips like this. We've got a 1 here, and it's the same length as that, all right? So we've got our x and by 1. And if we wanted to find the area of this piece, we would get x. It's just x. X times 1 is x, or 1x. Same thing. Now, what if we had more than one of them? Well, each one of these is an x, and we've got a 1 right here, so we have 3x. We just add them together. They have to have the same base, and that's like saying all of them to the 1. All right? Now, what if we have just little boxes like this? They're 1 by 1, 1 by 1, 1 by 1. Well, 1 by 1, the area of that is just 1. Length times width is 1. Length times width is 1. Length times width is 1. We add all these together, and we get 3. So in the end, if we had one big box, two big box, and we had 3 rectangles, this is x, 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 1, 1, 1, and then we have 3 little boxes, 1 by 1 by 1, we actually get 2x squared plus 3x plus 3. Now, if we wanted to make these into negatives, if we color these in, so if you're in the black with respect to money, that's a good thing. That means you're positive. If you're in the red, it means you're negative. All right. So if I colored these negative, or I colored them red, we would switch our sign to a negative, and it'd be 2x squared minus 3x plus 3. All right. So that's our intro into algebra tiles. So let's go back, and we're going to take a look at some notes that we had. And algebra tiles are used to model integers and variables. Blue, green, and gray are usually represent positive tiles. Red or black represent negative tiles. In this sense, we're going to use red. So which expression does each set of tiles represent? Well, we've got 3x plus 1. All right. Next, we have 2x minus 3. And then we've got negative 3x plus 4. All right, so, and then we've got negative 2x minus 2. Now, let's check this out. This is by 1, this is an x. We have 3 of these, so we have our 3x. And we have 1 of these, and it's positive, so we get 3x plus 1. Over here, we've got 2x, and if you notice, this is our x right here, minus 3, and there's our minus 3. We have negative 3x plus 4, and then negative 2x minus 3. All right. Now let's sketch these tiles to model each expression. Well, we've got an s, so it doesn't matter what variable we use. We could put any letter in there we wanted. It's going to look like this. We've got a 3. I'm going to use a different color actually, just so we know it's positive. And we've got 1, 2, 3, 4. All right, 5b. Notice how it's a different variable. 1, 2, 3, 4, 5. And we've got a negative, and I'm going to put these in red. 1, 2, 3. All right. What do we have? Oh, we got negative again, so that's going to be 4. 1, 2, 3, 4. And then it's going to be a 5 positive little squares. Over here, we've got negative 6w. And minus 1. All right. Polynomials and terms. All right, so polynomial is variables and numbers multiplied together. So we've got a couple examples: 3x squared plus 2x minus 5. That's an example of polynomial. Also, negative 3x. That's an example as well. A non-example would be something like root x plus 2 or 1 over x. It's not a polynomial. A term is a group of variables and numbers multiplied. All right, and that's something like 3x squared or negative 7. You got an invisible x there, and we've got 1/2 x cubed. All those things contain a variable and or number, and they're multiplied. Coefficients. Coefficients is the number in front of a variable. All right, so if I went 3x squared, 3 is my coefficient. Right? Degree of term. Now this is a little bit difficult, this part. All right, I'm going to put this in a different color here so we can see it. This is the exponent of the variable. All right, so an example would be 5x squared minus 2x cubed and plus 7. So the degree for each variable, that's a degree of 2. That's a degree of 3. And look at, if we put a x in there to the 0, that would make it to 1, right? So it's just like saying 7 in the end. So the degree of that is 0. All right. The degree of a polynomial is the largest degree of a term. All right. So if we have the same thing as before, 5x squared minus 2x cubed plus 7. If we want to find the highest degree or the largest degree of a term, therefore the degree of the polynomial, we look for the term with the biggest exponent. So this is a degree of 3. All right, constant term. This is when we have no variables. This is the term with no variable. All right, so that would be an example would be negative 3x minus 7. Negative 7 is my constant. It never changes no matter what we do with our variable. It doesn't matter what we put in for x. 7 is always going to be there. A mononomial. Mononomial is a polynomial with one term. And so that would be like 5x cubed or 7x squared y or just 15. Those are all examples. A binomial has two mononomials. All right, and they could be added or subtracted together. And so we could get x minus 2 3x squared plus 5x. You get the idea. And a trinomial, guess what? It's got 3 monomials. Alright, and we're going to be getting into that later on. So we've got 3 plus 3x squared minus 4x. That would be an example of a trinomial. Alright, now, which of the polynomials can be represented by algebra tiles? Well, guess what? Let's see. So let's write these as algebra tiles. We got, put them in a different color here. We got 3x squared and minus, so we're going to put those in red, minus 5x. 1, 2, 3, 4, 5. And then we've got 6 little ones. 1, 2, 3, 4, 5, 6. Alright? And I want you to try B. And so I want you to try this one on your own. And then we'll try this one as well. Negative 5m, so 1. Oh, that's got to be a red. 2, 3, 4, 5. Plus 6, so we're going to put that in blue. 1, 2, 3, 4, 5, 6. And, 3m squared. We've got 1, 2, 3. Perfect. Alright. Now, draw algebra tiles to represent each of the polynomials. In each polynomial, is it a binomial, trinomial, or monomial? So you need to try that on your own. And I'd like you to try these on your own as well. We're going to do one of them together. And so we're going to go 2x squared. That's these two. And then we've got a negative. So we're going to go minus 1, 2, 3, 4, 5, 6, 7, 8. 8x. And then we've got positive 2. Alright? The next thing, final thing we're going to do, it's called substitution. You know, when we have a substitute teacher in for me, you fill in for me, and they teach the same thing. So this is the same thing. If we substitute a negative 3 in for x, we're going to get 3 times negative 3 minus 5. Well, we do BEDMAS. Brackets, so we get negative 9 minus 5. You're negative $9, and then I say, hey, I need $5 more from you. So negative 9, and you're going to take away 5, so we're going to get negative 14. All right? I'd like you to try those other ones, please. And, yeah, we'll see you in class.